Welcome back to the Octopus Prime channel. In today's video we're going to be installing Portainer, a beautiful graphical interface for standalone Docker or Docker Swarm or even Kubernetes. We've been working through a series on how to set up a Docker Swarm cluster with a networking file system. And so as we've been working through that, we've been building up this system. First we set up 3 virtual machines with VirtualBox. We installed Ubuntu server on them. We created some storage volumes that we're going to use for our cluster. Then we installed GlusterFS, a networking clustering file system. And then we installed Docker, converted it to Docker Swarm, and now we have 3 Docker Swarm manager nodes that we're going to work with today. So if you have missed those things, you can catch up with those videos, but if you just want to see how installing Portainer works today, it should also be useful for that. So I'm going to switch over to my other screen here and make this nice and big for you. My nodes are already running, so I'm going to go ahead and log into them. I'm going to become root here because I need to punch in a whole bunch of commands and I don't want to be punching in sudo the whole time. And I'm going to just preemptively go ahead and log into all 3 nodes that we created previously. So of course, if you're only doing this on one node, this is not something you have to do. And one more. Hopefully these are nice and big for you so that you can see them. If you're ever wondering what terminal I'm running here, it's Z Shell. I'm on Manjaro desktop Linux. I am going to do a desktop Linux series soon for people who are looking for alternatives to Windows. Many people have never seen Linux desktop. They still think that Linux is just all terminal like this. This is server stuff. But if you're using a Linux desktop, that's a whole different game. You probably never have to go into a terminal if you don't want to, and it's efficient, it works, it stays out of your way and lets you get your work done. So I'm going to do a whole series on that. My students are always amazed when I introduce them to desktop Linux and they're like, why has nobody shown us this before? It's not a well-kept secret, but evidently it's still a secret. So I'm just going to show you here where I'm getting the instructions for Portainer today. If you go to the official Portainer documentation and you go to install Portainer CE, which is Community Edition, and set up a new Portainer CE server installation, you can do Docker standalone or Podman or Kubernetes, but we're using Docker Swarm today, which is what we've previously set up to continue with our cluster series. And we're going to do this on Linux because we have Ubuntu Linux running inside our nodes, right? So install Portainer CE with Docker Swarm on Linux. They have detailed instructions here of what's necessary, etc. I've already walked you through all of that stuff. And they have a nice video there. In the end, we're going to basically use these 2 commands in this whole page of stuff here, right? We're going to fetch this Portainer agent stack YAML file, which is basically a Docker compose file that tells Docker Swarm how to bring up this service or this stack, and then we'll fire up the stack. So that's where I'm going to get the commands from in a little bit. But first, we have a little bit of prep work to do. So the first thing I need to check here is, did my GlusterFS mount correctly? It did not. So here is the storage that we have mounted, but Gluster itself isn't mounted yet. So if I do a mount-A, and then I try this again, now you will see my Gluster volume is mounted. Why is this happening, Ernst? We did everything you said and it's not mounting correctly. Okay, this has to do with a network and timing issue, right? So certain services like networking need to be up before something like Gluster, who depends on the network, is up, right? And etc.fs tab, while it's legacy and it'll always work, isn't so good at ordering such things. So in a future video, I'm going to go through and address that, and we're going to make it a little bit more heavy duty or resilient, let's say, so that you know, the networking is always up, and then the Gluster file system comes up, and then Docker comes up, which relies on Gluster, so that that order of operations happen, and it's a little bit more resilient. For now, I'm not going to get into that today. I don't want to get into the weeds here. I want to keep my videos a little bit shorter. So we just need to make sure that it's mounted. Just know that there's a video coming explaining how to make this whole mount thing more resilient with systemd. Okay, so we know Gluster's mounted there. I might as well just check that on each of these. And there it is now. This is the thing when you have multiple nodes and you're not using Ansible to set up everything, then you get to do everything as many nodes as you have times. And there it is. Okay, so Gluster's mounted properly on all of our nodes so that we don't mess up there. Okay, so what we need to do now is we need to go to our mount GB0 folder here. Let's look in there. Oh, there's still some test files from last time. Let's just delete those. And what I'm going to do here, let me clear this out, is I'm going to make a folder structure. I'll use -p so it creates the whole folder structure. And I'm going to call it docker/volumes. I do make a Docker folder with a volume subfolder, and then all of my Docker volumes are contained in there, so they're organized, and then I could use my cluster storage also for something else if I need to without interfering with all of my Docker volumes. And what I want to do here is make a folder called Portainer_Portainer_data. I will explain shortly why there's two Portainers there. We could actually just call it Portainer_data, and it would work fine, but I like to keep my folders and my volume names matching. So when I'm looking at a Docker Compose file and it has a specific volume name in it, I always know exactly where to go in my folder structure because it has the exact same name. And I just do that for simplicity because I assume I'm going to forget what I named something, which is probably a good assumption. So I'm going to create that there, and of course that's going to automatically appear on all of the nodes. So there's the Docker folder, right? So on node 3 here, it's already there. Okay, so that's step 1. Now we need to pre-create the Docker volume that Portainer is going to use. If we don't do this, what will happen is Portainer will create a named volume locally on the node where you install it. And what happens is if that node goes down, Portainer goes down with it. It can't automatically move to another node with its storage. Docker does not, I repeat, it does not move storage volumes across swarm nodes. I've seen some stuff online where people are telling other people that yes, it does. It is not true. It does not do that. Okay, so what we need to do here, when we create volumes with our nice Gluster system, we need to create the folder only once because it's replicated, right? But we do need to create the Docker volume ahead of time before we set up a new stack, and we need to do it on each node. Okay, so I'm going to show you here how we're going to create this Docker volume. So I'm going to just check here, Docker volume ls. You see there's no volumes currently on node 1. So let's go ahead and create one. So we're going to say Docker volume create, and -d means driver, use the local driver. And I have all these options here. Don't ask me where I got them from. It took me a very long time to find these deep in the depths of documentation somewhere, and I've just noted them in my notes application, and I just use them. I don't know if I could find them again if I tried. And -o means options, so we're going to give it some options here. So the first option is type equals none. Why? Couldn't tell you. Second option is option equals bind. A little bit weird that you have to tell an option that it's an option. Last option is device. Oops. If I can spell today. And here's where we're going to point it to our Gluster folder. So it's going to be mount gv0 docker volumes portainer underscore portainer underscore data. So it's going to bind mount that folder into this Docker volume. And I already noticed a error here. I didn't even spell Docker correctly for you. If you use different names and stuff, then you'll just need to be careful that you align everything up. So if you do it the way I'm showing you here with the same names, then everything should just work. Test it out in the VM the way I'm showing you, and then you can always tinker with it and try it on the real machines however you'd like. And then the last argument here is the actual volume name. So when we install Portainer, it's going to have a server component and a worker component. And the server component is going to go ahead and create a Docker volume called portainer underscore data. And that's where it's going to store all of its stuff in, right? So when I do this here, so let's go ahead and do that. And let me show you now that volume is there. But if I go to node 2 here, it's not there. So it just proves to you that Docker Swarm does not move storage volumes from one node to another and copy it. That's a whole different clustering problem, and which we're solving with GlusterFS. It just takes a little bit of extra work up front when we're setting up a stack, and it doesn't matter whether we're in the terminal here or whether we're in the Portainer UE. We always have to create the volume ahead of time on each node. Okay, so I'm not going to retype all of that. I'm just going to go ahead and copy it, and I'm going to paste it here. Make sure it's there. It sure is. Paste it here. Okay, so I'm giving you this formula to make this work. It might take a lot of time to figure out all of the right dance that you have to do to make all of this work and all these pieces fit together. What I'm showing you here is all going to work. Okay, so we now have a Portainer data Docker volume on each node, and it's all, but each one is pointing to the GlusterFS folder, which is of course replicated, right? So they're all basically pointing to the exact same place. Portainer does not know that. So we're going to now install Portainer. We'll do it in node 1, and when it installs itself, it's going to use the volume that we pre-created. If the volume doesn't exist, a Docker Compose file will create it, or a Docker command will create it. If you've already created the volume, I've discovered that it will use that volume that's existing there. So this gives us full control over that volume, and then we can point it to our clustering file system, which is very useful. But if you don't know that, it can cause you a lot of headaches and trouble at the beginning when you're figuring that out. So there you go, give you that for free. Okay, so now that we've done that, we're going to go back to the Portainer instructions here, and I'm just going to go ahead and copy this command here, and it's going to fetch this YAML file. Oh, before I do that, I want to go to my root folder. So I'm going to go to my root home folder. Since I'm root, it's /root. Then I'm going to run this command here. Okay, so it downloaded this Portainer agent file here. So let me just look at that for a second to show it to you. So it's basically a plain Docker Compose file, and it has two services in it, an agent and the Portainer server itself. And you can see the volumes it's using there and the constraints it has. So the Portainer, so the agent can be installed on any node that is a Linux node. The Portainer server can be installed on any node that's a manager. Well, we have 3 managers right now, right? If we add to our cluster now, if we put up to like 10 nodes, we would have 3 managers and seven workers, right? So Portainer by default wants to only install itself on manager nodes. So we're going to install it, and it's going to look at the node roles, and it's going to pick one randomly, evidently, and install itself on a manager node. You would think here in the replicas that, well, Ernst, we have 3 manager nodes, we're building a cluster, don't we want 3 replicas? The answer is no. The way we're going to set it up is Docker Swarm server is going to run on one node, and if that node goes down, it should automatically come up on any of the other remaining nodes, and because we're using GlusterFS as its storage, it will just resume exactly where it left off because it's looking at the same storage. Running multiple replicas on clusters is actually a fairly complex problem. You have to have applications that support that. For example, you could have one database instance running and 50 web front ends running that are pointing at the same database, but the database has to be capable of multiple simultaneous concurrent connections and row locking, and it depends if you're using SQL or no SQL database, etc. So it's complicated, right? So we don't want that. We're only going to run the Portainer server on the default one node, and it's just going to move around because it can. If you did it the way that they say in the documentation, and you only have one manager, it will always stick to that manager, and if that manager node goes down, so will Portainer. Okay, and you can see at the bottom here they have Portainer data. You see, but Ernst, there isn't a Portainer underscore data. It happens because of the service. So what happens when you bring up a stack? We're going to call the stack Portainer. It puts the stack name in front of any volumes that are created as part of that stack. And so if the service or stack is called Portainer, it will go Portainer underscore and then the actual volume name, which happens to be Portainer underscore data. So that's how we end up with the 2 Portainers. Okay, so enough about that. So then we're going to run the second command here, which is just deploying it. So it's going to take that YAML file and it's going to create a deploy a Portainer stack into our cluster. And then we get to start doing the fun stuff. So let's do this. And so it's going to create its network. It's going to create all the services for the Portainer server and the agent. Now let's look here. So if I say Docker service ls, you can see that the agent hasn't come up yet on all the nodes. The server has come up on one of the nodes already. Okay, and it's serving up. So we'll give it a minute. If I check this again here, now everything should be up. Now, you ask, where did it actually put it? It put it on node 1, right? Because that's where you ran the command. Not necessarily. You told this cluster, hey, go start up this stack. The only way you can control where to put it is with placement constraints. They're assuming you only have one manager in your Docker Swarm cluster, which would be foolish in a production system. So it's going to go to any node that has the manager status. Well, we have 3. So didn't it go on node 1 where we installed it? Not necessarily. It's going to pick one in the cluster and it's going to install itself there. So how do we check that? So let's just check what Docker's running. So Docker PS, so node 1 here is only running the agent. Let's look at node 2. Node 2 also only running the agent. Node 3, aha, that's where the Portainer server is running. Now, you don't have to go to node 3 to access this. So we're going to access it on port 9443. It'll have a self-signed certificate, HTTPS, right? We can actually access this service from any node in the cluster. Because Docker Swarm will have this networking layer, that any request coming into any node for a particular service, it will automatically internally route it to the correct place. So even if I come to it from node 1, on that port 9443, it'll automatically route it internally to the correct place. Let's check this out in action here. So I'm just going to use Firefox here. I don't normally use that, but let's try this out here. Actually, I always use Vivaldi. Lovely browser. Let's go to port 9443 because I want to show you a little bit of a glitch. So firstly, it's a self-signed SSL certificate, so you're going to get this warning. Totally fine. It's our own server infrastructure, so it's fine. Well, look, Portainer loaded, even though we're going to node 1, even though it's running on node 3, right? So I'm going to give it a password here. So you should, you can pick whatever username you want. I use admin. And then you need a password at least 12 characters long. Hopefully you're using a password manager like Bitwarden, which has not been hacked yet as far as I know. It's what I use for all of my passwords and secrets. And they also have a secrets manager for automation tools like Ansible and Terraform and all of that stuff. Highly recommend Bitwarden. It's open source. If you want to use it for a business, also very affordable. For a whole team of people. I share all my passwords and stuff with my wife. So I don't want anonymous statistics. I'm going to click create user. And now, had I gone to node 3, I think we wouldn't have to go through this. But somehow we're running this sort of from the perspective of node 1, which doesn't have Portainer server running on it. So I'll just show you what this looks like anyway. So we click add environment, and we're adding a Docker Swarm environment, right? So you could add standalone, you could add Kubernetes. That'll be a different video series. We just want Docker Swarm. We're going to start the wizard, and we want a socket connection. Now you don't need to do any of this because our YAML file already set up all of this connection. Okay, so I'm going to tell it what to call this swarm, so I'll call it virtual swarm. And I'm going to click connect here, and it's probably going to fail, at least for a moment, because we're on node 1 and not node 3. So let's see what happens here. So I'm going to choose socket, and which, by the way, is the only connection type you can use for swarm. For the other, for Docker standalone and Kubernetes and stuff, then you would use the correct version for that. But for Docker Swarm, you have to use socket connection. Okay, so you give your swarm a name. I'm going to click connect. It said failure. I'm going to refresh this here, or I'm going to refresh the. Yes, I'm going to go to the home. I think it's a little bit of a Portainer glitch, to tell you the truth. It says it failed, but it did not, because here we are. Here's our home screen with our virtual swarm. So it says we have 3 volumes, 4 images, 12 CPUs, 25 gigabytes of RAM, 3 nodes. So I can click on this, and now we're in Portainer. I love Portainer. I'll give you a quick tour. The video is already getting a little bit longer again today. Here's the stacks. So you can see any software stacks. In the next video, I'm going to show you how to launch your own open source private local AI stack with OpenWebUI and Olama. Fantastic software. I'm going to blow your mind with what you can do with it for all you people still using OpenAI, which you can still actually use with OpenWebUI. I will show you how to do that. I just did a conference session on that a few weeks ago and had fantastic reviews, and people were just walked out of there like, wow. When you look in a stack, it shows you what services are running. When you look in a service, you can see all the information about it. If you go to tasks, you can see where it's running. So here we're running on node 3. I think my video bubble is in the way here. We're running on node 3 there. You can see what containers are running, right? So this shows all containers running on the entire swarm and where they're located. Okay, so we can see there's 3 agents because we have 3 nodes. So it's on node 1, 2, 3. And we can see there's one Portainer CE, and it's on node 3. You can see what images we have downloaded. So these are Docker images. I'll put myself back in the corner here where I belong. It'll show you all the networks that have been created. It'll show you all the volumes. We'll check it out. Here's that volume that we created. These two are saying unused, and the node 3 one is not saying unused, which means that because our Portainer server is running on node 3, it's using the volume there. If we unplugged node 3, it should automatically fail over to node 1 or node 2, and then you would see these volumes, whichever one it moved to, in use. That's why we set up the volume the way that we did, so that the Portainer server can fail over just like a normal service would, so that you're not left in the dark if the node where your Portainer server is actually running on goes out. Okay? You can store all of your configs in here. So config files like for web servers, etc. You can have them loaded inline in your compose files and so forth, and your secrets as well. We can look at the swarm details here. So you can see all 3 nodes are there. They're all manager roles. They all have 4 CPUs, just like a Raspberry Pi, 8 gigs of memory. I've been buying the 16 gigabyte Raspberry Pis. They're fantastic. Shows you what version of Docker Swarm they're running and their IP addresses and whether they're ready and available. And you can change that so you can drain a node, etc. So that's sort of the overview of Portainer. And next time we're going to come in here and I'm going to show you how to create your first stack. And we're going to create a private local AI that doesn't betray you. It will preserve your data sovereignty. It doesn't send your information out for harvesting. And why am I starting with that? Because then the next example I'm going to show you is how to install N8N, a fantastic agentic workflow application that lets you create automation workflows using AI or LLM agents to automate things for you. You can do some pretty crazy stuff with that. And then I'm going to do some video series on N8N with that. But I'm going to spend a little bit of time showing you Open Web UI next time. So in the next video, we'll install this private local AI stack. And you'll see how simple it is to get that up and running here. But for today, this was the goal of the video. So we now have Portainer running on our Docker Swarm cluster. So now we don't really need to do any more terminal commands. The one last thing I do want to just look in the terminal here is I can do this from any node, but if I go look in the Gluster folder there, so there's the folder that we created previously, which was empty, and now Portainer server has put all of its config stuff in here, right, which is all replicated. The other thing that can happen if you don't do it this way, if the node dies that goes down, which had happened, a hard drive failed, this configuration is lost with it, right? So this way, and then you'd have to reset up Portainer. You'd have to re-import all of your services and stacks and everything, which I had well documented, so it was a bunch of copying and pasting. It wasn't a big deal. But then I learned from that, okay, we need to make sure that Portainer data is also replicated. So if any one of our 3 nodes goes down, our data is perfectly safe on the other 2 nodes. Even if 2 out of the 3 nodes went down, it would be fine. It could be a little bit iffy what state it was in the last second before it died. Anyway, I'm going to end with that. Hopefully this is helpful to you. Hopefully you're loving the direction we're going with Portainer here, and the direction we're going with this. And so I'm going to do one more video now to get the local private AI stuff going in the next couple of days here and release that ASAP. Sorry for a slow release for this one. I had some family stuff this week to deal with, and family comes first. and I'll do the other one as soon as I can and release it also as soon as I can. And then we'll do some fun engineering stuff that will be exciting, that hopefully nobody will get themselves in trouble with. Anyway, hope you have a great evening. If you like this video, like and subscribe, and send me a note. Tell me what you think of things, and you know, keep it professional or kind. And wish you guys a fantastic weekend, because it's Friday here when I'm recording this, but it might not be when you're watching it. Anyway, have a great evening wherever you are and whatever you're doing. See ya.